Good morning, my superhuman friends. If it seems like I'm kind of jittery and disorganized, it's because I am. But before I explain that, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, I was very nearly not here. And right before going live, I still didn't have my microphone working and other stuff. So what happened was last week my iMac died, and it was while I was using it. I was actually sitting here using it, and all of a sudden it was like someone just pulled out the power cord. So I'm pretty sure the power supply in it is dead. And luckily my wife has an old iMac that she hasn't used for a couple of years because she just does everything off a laptop. So I wiped that and restored from Time Machine, pulled my iMac back up onto it. So right now I'm using a lower spec iMac than I have been using in the past. And, oh sorry, I just noticed something was stuttering. Hopefully it's working. But the result is that I've had to set permissions on everything. So things like HDMI and audio, and I was just trying to get things working. So right before going live, I still didn't even have HDMI capture working properly. My Logitech Brio camera, which is the one you're looking at me at right now, was not working. It was just a black screen. So I've been frantically trying to make stuff work. And I think we've got it. Hopefully you can hear me. So, good morning Ingmar, Kableti. Oh good, thanks. Dodgy, Austin, Devet, Dustin, Bob P. Bob P? Ah, is that Bob Powers? I hope it is. Mike, g'day. So, alright. Because I've been rushing, I still feel like jittery and still trying to get everything sorted. But we will get there. Okay, a couple of deep breaths. What have I got? Oh, and my OBS scene switcher is not set up. So that's actually something that is worth getting going. If I'm going to be showing stuff on the overhead camera and switching between cameras, the scene switcher is useful. So while I make you wait, I am going to just see if I can get this working. Color doesn't look right though. No, the Logitech camera is not as great. Actually, I can probably improve things a little bit because I have another light over here which will... let's try this. That throws a bit more light at the front at least, so the camera doesn't have to work so hard. Alright, touch portal. Aaron said, light switch controller in the background, is the project progressing? Yes, I'm going to talk about that. That is one of the many squirrels that we will chase today. Okay, so it wants to receive keystrokes from the application. Open system preferences. This has been my world for the last week. Just about everything I do has been authorizing things to do what they want to do. All of the sandboxing and security stuff in macOS is useful, but the result is that if you switch to a new computer, all the things that you had running previously you've not got to reauthorize. So I've just had to reauthorize Touch Portal so that I can get my OBS scene switcher running. Okay, I think it's going to be time to crack open a drink early today. Now it's probably trying to connect to the wrong IP address. I think it is 214. Okay, so I have a new IP. Touch Portal settings. Come on. Here we go. It won't take that long, I promise. I'll get there. 214, touch portal, connect, Come on, connect. All right, let's just switch to the desktop and see if this works. Yay! OBS scene switcher is working. Looks like we're back in business, folks. Alrighty, so today, Sion, hey, thanks for coming along. Mike Clauser said, switch to Big Sur. Yes, I did, partly because, well, the iMac, my main iMac, is too old to run Big Sur. It's a very old machine. So the one that I've switched to, this iMac that I'm using now, is a couple of years newer. This is a 2015 model iMac, but it's lower spec. So it's newer than my normal iMac, but it's only an i5 processor, not an i7 processor. And it's spinning, I think it might have a Fusion drive. My other iMac had an SSD. So anyway, all right, where are we at? Yes, we will get into some Unity hacking because that is a fun thing. But there are a couple of things that I wanted to talk about first. Two things, two squirrels. And the very first squirrel is, after last week's time zone change, let's have a look at something. I've been thinking about maybe radical, like just changing the time of the live stream. Now, there is going to be this is going to be an example of survivor bias, which is a really interesting concept. You should check that out if you haven't come across it before. Survivor bias and bombers in World War II. So the 10 a.m. Sunday for me, locally in Melbourne, live stream time, works out pretty well. I get a couple of hours, then go to lunch. It's a leisurely get up in the morning. I don't have to rush to get up to live stream at, Sion time or anything ridiculous like that. So I've been thinking about I'm pulling up stuff on my desktop, which I will show you in just a moment. Now, my browser is being very laggy. The computer is working hard. I wonder if I'm dropping frames. Don't know. Let's see. What does OBS think? No, it thinks it's okay. It says 0 dropped frames so far, which is nice. It's hanging in there. Alright, so analytics. Anyway, last week's change to the live stream time, and then seeing something in Google Analytics made me, come on, subscribers, watch time, somewhere in the analytics, maybe it's in the audience section, audience. Aha, here we go. Okay, so let's look at this. So this is YouTube Studio for Superhouse, and this is the back end, so showing you all the stats of what's going on. Let's zoom that in a bit. Can we get a bit of zoomage happening? Make it easier to read. Not that much. Maybe about there. And move it across here. Okay, so this little heat map chart thing here got my attention. And so what you're seeing here is time of day in my local time zone, so day of the week and time of day and when my audience is online. Now the thing is that a lot of the views for my prepared and edited videos come from the US. So the time zone kind of biases towards the US. So what you can see is that the spots where most of my viewers are online is stuff like between 10 p.m. and 4 a.m. or 3 a.m. So it's overnight, through the midnight hours. If I was doing night shift, that would be the time to be live streaming, because that's when people are around. And look at this, Sunday, 10 a.m. Where's 10 a.m.? Right about here. Phew. So this section here where I normally do the live stream is right when my viewers are not on YouTube. So, now if I ask you, this is the survivor bias thing, if I ask you what time I should live stream, it will tend to be people who make it to this live stream are the people who can make it to the live stream and it suits their time, and therefore they're going to be more likely to say, stick with the current time. So if I ask the existing audience, I'm pretty sure you're all going to say, stick to the current time. But it may make sense to do something like go to maybe 8 p.m. on a Sunday, just as a hypothetical. So if I did a live stream between 8 and 10 p.m. on Sunday evening, then more people are going to be online. Maybe that would be better. Maybe that would suit you as well. I don't know. So I pulled up this thing. So this is a really cool little time zone conversion thing. So where are we? Sunday. If I go for the green one down the bottom. If I go for Sunday 8 p.m., which is down here, that makes it, where are we? Makes it midnight in Germany, which would kind of suck. 11 a.m. in the UK, that would, 11 a.m. Sunday, that's kind of a relaxed time. 6 a.m. US Eastern time, makes it really early in the morning if you're, West Coast US, and makes it comfortably in the evening if you're in China, Japan, India, all those sorts of areas, and New Zealand it would be 10 o'clock. Anyway, I'm not deciding anything on that right now. That is just something that I came across this chart and it just made me think, hang on, I'm live streaming right here in the worst possible time when people aren't online. So, hang on, I've got a, where are we? View, actual size. Okay. Now I can go, all right. So Austin said, I think it would be worth to shift the time and test it. Normally I think I see 50 to 150 people watching the stream live. Yeah, that's pretty normal. And Mike says daylight savings time added to the mix. Sion, so now you know specifically why I get up at 5 a.m. to stream early on Wednesday mornings. Yes, that's dedication. Sion, you are very dedicated. I'm not quite that, what's the word? Well, dedicated, I suppose, is the word. What it comes down to is I'm doing this. How do I put this in a nice way? I don't want to put myself out. I'm doing this because it's fun, and I'm not doing it because I want to, grow a huge audience or something like that. And so I don't think I would make the sacrifice that Sion does of getting up at 5 o'clock in the morning in order to do a live stream. So that's very admirable, but I'm not going to go to that much effort, sorry. Okay. But then, okay. Looks like Europe, including UK, seems to be your biggest audience overall, is what Aaron said. Yeah, so somewhere in here. Oh no, look at this. Geographies. United States, 12.9%, United Kingdom, 8.3%, Australia, 6.2%. And of course, Australia is going to be slightly higher represented than, just the global average, simply because that's where I am. And I think a whole lot of the people that watch the channel are people that I know personally, so it just comes from having your friends watch it, which means it's people in your same time zone. So, dashboard, while I'm in here, what else is going on? Nothing much interesting. Yeah, well, for those who care. There are stats. I'm happy to show any information. Oh, look at this, estimated revenue. So $296, that's the revenue for the month out of YouTube. So that includes ads on videos, and it also includes super chats and that sort of thing. And that can vary dramatically. So often I'll get 0 super chats. Sometimes I will get quite a few. So I might get, you know, $50 worth of super chats on a live stream sometimes, and that pushes up this estimated revenue. So let's see, actually, revenue. Somewhere in here, there should be some interesting figures. Okay, playback-based CPM. That's really high. $16.12. That's really high. So RPM, which is revenue per thousand. M for mille, for thousand, like millimeter. It's the same sort of root as millimeter. It's a thousandth of a meter. And RPM means revenue per thousand views. So for every 1,000 views of my videos on average, I get $4.10, which is okay. Anyway. Oh, you can see the revenue has dropped off dramatically over the last few months. This is a squirrel I didn't expect to chase. I wasn't going to be getting into all of this sort of stuff, but look at this. So this is revenue, November and December, $755, $685, and I think this might be because there were some big super chat contributions in those periods, and that is what artificially pushed those numbers up. But these numbers down here, this is more like what my advertising revenue is. So January $336, February $278, March back up to $337, April it's $140 so far. Where are we in April? So it's the 18th of April. We're most of the way through, $140, so it's going to make it up into the 200 and something region in April. Anyway, actual size. There we go. All right. Oh, Dodgy said 8 PM would be fine. Okay. I would like, yeah, watching in, oh, Ben said, watching in silence as my 20-month-old grizzles about going down for her day sleep. So if I just hit mute and do this and maybe, you know, wave a lot, then so that was one thing. As I said, there were 2 squirrels I wanted to chase. One is the time. Oh, and the other thing is, working on this, this multimeter hacking thing, it seems to me that there are really a couple of different types of live stream that I could do. And I like the idea of doing 2 live streams a week and having them be for specific purposes. So I could do one live stream, like a Sunday morning thing, which is where I just talk to you about all sorts of rubbish and maybe get interesting people on, hopefully, and do some interviews or whatever. So I've had a couple of people on doing interviews, which I thought has been really fun. I've enjoyed that, and I need to do more of that. And then do another live stream at a different time, which is just working on a project. You know, things like this multimeter hack. The sort of thing that I don't necessarily have to be talking continuously, because with this live stream, I kind of feel the pressure that it's like being a radio DJ. You know, the last thing that a DJ wants is dead air, when there's silence. So I feel this pressure to just keep talking, no matter what. You know, what else is going on, and if I'm working on something, then I have to keep talking. So what I could do is have a different live stream, which is more about working on projects, and I'd be able to do things live and, you know, sit and think about things a little bit. Pause for a minute while solving problems and getting feedback from the chat. That, I think, would be a really fun thing to do. I'd like to do that. Now, and Celtic Beast said November and December equals everyone setting up automated Christmas lights. That reminds me. Last week on the live stream, this is kind of a squirrel, kind of not. The sign, you can see it's working. And there is no flicker towards the end. So this is with the brightness turned right down. It's down to like 5% brightness at the moment. Kablooty says, turn the mic gain up. Stop talking and we can listen to your brain cogs whir. It'll just be rusty gears grinding against each other. Yeah, I can get a neural implant. So, last week I mentioned the sign and that it was working again. But I never actually explained the outcome. We did that live hacking thing where we went through and found various problems. But then after the live stream, this really highlights one of the problems of doing things live and trying to stay engaged while I'm working on things. And I can't really think all that clearly while I'm doing it or while I'm trying to talk about what I'm doing. So on that live stream a few weeks ago, we spent a couple of hours messing around with the sign and found a few things and didn't really make a huge amount of progress. And then after the live stream finished that Sunday, I just thought, stuff it, I'm just going to fix it. And within like half an hour, the sign was totally functional and fixed. And it's just, you know, it's been up there since. And so what I ended up doing, I wonder if I should pull it down and show you. Yeah, let's do that. This sign has been quite a topic of discussion for a while, so I'll show you how it all turned out. I'm gonna take power out of it. I've got this little XT30 connector that I stuck on the back. And in a moment we will switch to a different camera. What are we going to do? Overhead, overhead, overhead. Now, can we zoom out as far as possible? Well, not necessarily as far as possible, just zoom out a bit. All right, now, the way James had this wired up originally, I've got rubbish all over my bench. Get that out of the way. Was, see these wires here, the orange and green wires? These came from little 5-volt DC regulators. And there were multiple regulators across the back here. So there was 12 volts being, I can't quite see what you can see. All right, so 12 volts being fed in, and then that was going to multiple 5-volt buck converters, and that was being then fed into multiple places on the PCB. So I've ended up going for a bit of a simpler approach. So what I did, you can see here, in fact, let's get that zoomed in, because what you can see here is a big bridge between the planes on the PCB. And maybe I'll take this out of the frame, it might be a bit easier to see. It was glued in, but I removed all the glue so that I could access it. Now, what was going on was each of the 3 PCBs that are in this, I'll turn it around, zoom out. So we've got one PCB for super, one PCB for the logo, one PCB for house. And they have they have a 5-volt power plane on one side. I can't remember which is which, but yeah, 5-volt power plane on one side, and they have the ground plane on the other side. Oh, it must be 5 volts on the back, ground on the front. And so there were power connections to these boards coming from the different converters feeding into it. So there were multiple converters feeding into each board, but each board was being fed independently. And, well, kind of independently. These wires were all tied together, all soldered together. So what I ended up doing was taking a bit of a sledgehammer to crack a nut approach, and what I did was tie the planes together. So on the back of this is the 5-volt plane, and I got out a scalpel and scratched off the solder mask on the PCBs. Like basically I scratched a strip off the solder mask straight across the joint between those two boards. There we go. In fact, let's see if I can get it under here. Will this work? I'll need to get some focus happening, but... And I want minimal zoom and get a bit of focus. Yeah. What's that looking at? Oh, that is replaying a video right now. No, I don't want to be doing that. I bumped the, how do I stop it? I'm going to turn off the little camera. It's got this stupid, there we go, goodbye. And I'll turn it back on again. It's got a really annoying menu system in the camera. Now, which way? Not that way. Bring it up. Better, okay. I think mildly better. So what I did was just grab a scalpel and I scratched off the solder mask on both of these, and then I got some really big, thick, chunky cable and soldered it directly across between the planes, and that tied the planes together. And you can see that I did that on the back of the PCB, and I did it on the front. So you can see there is a tie across here, and another one across here. So effectively what it did was just make the ground plane on the front of the PCB one continuous ground plane, and it made the power plane on the back of the PCBs one continuous power plane. Then I got this heavy gauge silicon coated wire. This is good quality stuff that's used for drones and things. I love this wire. It's really good. It's got a very, what's the term, not thread count, but it's the number of cores. So with wire you can have, there is a specification for the cross section, but that doesn't give you the whole picture. You can have a single core cable with a large cross section, and it will carry a lot of power, but it won't be very flexible at all. Or you can have cable with just a few cores and it will be slightly flexible. Or you can have lots and lots of tiny cores, the same equivalent cross section, but the cable is very, very flexible. And that's usually what you have on things like multimeter leads, where you want the cables to be really supple, but still have very low resistance and, you know, good electrical characteristics. So this cable, which I really like, is silicon coated, and it has a very high number of cores. So it is very flexible, like it's really wobbly. And the silicon insulation is nice. It's much nicer than that crappy PVC insulation that you see on a lot of things. Anyway, so I got some of that cable, and you can see I've hot glued on here for strain relief. Super high tech, and connected directly to the power planes. And I drilled a hole down here through the glue, passed that one through, bent it over, and once again scratched away and soldered directly on there. And I also added we were adding caps on the live stream, so those caps are still there. I added another one here, and now what I do is feed 5 volts DC straight in here, and it works. So it's kind of a brute force solution to the problem, but it got us there. So I ended up going for a high current 5-volt switch mode power supply, which is down there somewhere behind the chair with a cable that goes up, and it just sits up there. All right. Now, one thing that I have not been able to figure out, this seems like the most obvious thing ever, but I just don't get it, is where does how do you make WLED save its settings? There must be some obvious way to do it, like a button that you click. And I just haven't seen it. Because every time I power this up, it comes up with a with whatever its previously configured thing was. And as you'll see, it'll be orange and at full brightness. So on camera now, if you look at that, that'll just be a big blur, I'm sure. You won't even be able to tell what is on that. I have to turn the brightness way, way down before the camera can distinguish individual things. So if we come into here, yes, okay, you can see my desktop and you can see the sign. It's right behind my head, bad position. All right, so it always comes up with this default. And then if I go into, no, not config, back. The UI confuses me. So if I go for, I don't know, fire flicker, that'll do. Turn the brightness way down. What is fire flicker doing? Not very much. All right, how about fade? No. Random colors, ripple rainbow. Come on. No, I need to find one that, or maybe just rainbow. Yeah, rainbow, that's a good one. But then you can see the motion in it. And if I switch back to the front camera to make it a bit bigger, see, now you can see that it's distinctly the Superhouse sign and all the colors are flowing through it. Looks much prettier. I'll just bring the brightness down a fraction more, if I can. Yeah, something like that. That looks kind of cool. Needs to be just a little bit brighter. Maybe there. Now you can definitely make it out and you can see the colors sliding across. All right. Oh, okay. So, Stephen said, I don't know if you can change it from there, but you can change it from the code. Okay. So Dustin said, do you just want to set the default startup effect? Yes. Yes, I do. So what I would like, James said, did I miss the DMM stuff? That board doesn't look like it's for the serial. No, it's not. But it's kind of the thing that inspired the DMM project. We haven't got to that yet. We're squirrel chasing. It's still early in the day. So yeah, basically what I would like to be able to do is just pick something. Oh, what's PC mode? Oh, PC mode, I see. So that's for the, if I come back to here. Yeah, so right now it's set to rainbow. The brightness is set nice and low. And I just want to save this and make it so that whenever it powers up, these settings are what it uses. Config LED preferences, scroll down to the defaults. Nice. Config LED preferences, defaults, default duration, cool. Mode, oh, okay. No, fade, sunrise, advanced. Am I looking in the wrong place? Default target brightness. That's set to 0, which, oh, that's timed light. Save it to a preset. Okay, so set current preset cycle setting as boot default. Let's try that. Oh, default brightness. I'm going to set that to like 30 or something. And set current cycle as boot default. Yes. And save. Okay. Maybe this will fix it. I don't know. All right. Anyway, that is getting slightly off topic. Peter, hey, good morning, Peter. So Peter says, how's the multimeter hack going? It's not yet. All right. No, we're still squirrel chasing. So, all right. Multimeter hack. Now, something interesting that just came up. So when I posted last night on Twitter saying that I was doing more of the hacking, the multimeter hacking today, I got a couple of responses saying that the UT61e seems to be either discontinued or not really available. And so that got me, yeah, it got me wondering. UT61e. So before we go any further, I mean, I'm still going to do it because I've got the multimeters myself, but I'm curious to know whether the UT61e has recently been discontinued. And it looks like it's still listed on the UT61e flyer, models, comparisons. It's still listed on the Unity site. So, yeah, I don't know. Let's have a look. Not damn. Banggood. Let's look at Banggood and see if they've got the UT61e on here. UT61e. Someone was mentioning that there were a few still available. So that one is, why is that one $95 and this one is $68? Oh, it's the different edition, I see. So that one is the UT61e Plus. Ah, so maybe this is what's going on. Let's side by side these. All right, so the UT61e Plus is the new model. Oh, and this one says restocking will be available soon. So this one is not available right now. I've seen this available though in the past. And the UT61e, the non-Plus version, is available in stock. Ships in 24 hours. So, I don't know. Hopefully they don't discontinue the 61. What might be happening is that they are phasing in the 61e Plus to replace the 61e, but the 61e still seems to be available. What I'd like to know is whether this one has, let's see, well, they've got Plus versions of the B and the D as well now. Yeah, it's probably just new generation stuff. I wonder if it's got the optical interface on the back. Let's see. Can we see any specs on here? Optional accessories. Oh, Bluetooth plug-in. Well then. Maybe I should just get myself UT61e Plus and set up Bluetooth. I could make a Bluetooth to MQTT gateway. Solve the problem. Yeah, in many ways that's actually a nicer solution because Bluetooth can be much lower power. Doing this with Wi-Fi in the meter, my main concern with this is just how to power the thing. Like if I put something like a Tiny Pico in there, Tiny Pico can use a very, very small amount of power when it goes into sleep mode. Xeon specifically designed it to be as low power as possible, but you just can't get around the power requirements of communicating on Wi-Fi. The reality is it just takes a bunch of power. It takes hundreds of milliamps in surge on startup while it does its calibration of its radios. So maybe I still want to keep going with this project because it's kind of interesting, but maybe the more sensible thing to do would be to get something like a UT61e Plus with Bluetooth, and then get a Bluetooth, make up, okay, ESP32 already has Bluetooth, So you could probably do this with nothing but something like a tiny Pico plugged into a power supply and some code loaded on it, and that's it. But anyway, where's the fun in that? Well, actually quite a lot of fun, but all right, so it looks like the UT61e is still available, but I don't know for how long. This is actually a pretty old multimeter. I've had mine for many years, and when the design came out in 2007. Yeah, when we last week when we looked at the data sheet, the schematic for this, I think it was dated 2007. So it's been around for a while. Oh, look at this. It's talking about the data stuff here on the 61E with the RS-232 interface. Pmin, Pmax, so it's got peak, max and min. And that's the adapter. Oh look, there, oh cool, check this out. This is the transistor adapter. So last week when we were looking at the schematic, there was the little section in the schematic for the transistor tester with the contacts where you can grab a transistor and shove its pins on and then measure its characteristics. And this is what it looks like. It plugs into ports on the front of the meter and then it exposes these little contacts, and it looks like it's got pins in, like holes in here where pins can be stuck in, and you can measure, it says RC in the middle there. It's probably very hard for you to read. This is, it's just molded into the plastic. But yeah, stick that into the meter and then you can do transistor testing. Anyway, what are we doing? What are we doing today, folks? What are we doing today, brain? Same thing as always, taking over the world. Oh, James said I've got that transistor adapter. Cool. Yeah. The culling beast. Did I just hear John say he was going for the off-the-shelf option? There goes an extra weeks of streaming content. Yeah. Yes. No, I'm kind of interested in this. I like the idea of hacking around on this multimeter. And Aaron said, I assume the Plus model has a bigger battery to accommodate the extra draw. Yeah. Okay. Oh, Leland said, talking about it in general, I wouldn't touch Unity with a 100-foot pole. That's interesting. So have you had, I've missed a whole lot of chat here, so I don't know what Leland is following up. Oh, James said I bought the UT61e a month or two ago. Oh yeah, so Tim said the UT139C is the new budget DMM, albeit not as precise. Yes. So, okay, I was going to talk about that as well, because that one was also brought up on Twitter. I can't remember who. My memory for assigning correct credit to people is very poor. So, where are we? Shipping delay, blah. All right, so it seems Leland doesn't like the Unity meters, but I'm not sure specifically why. So, Leland, if you've had bad experiences with Unity or whatever, I would like to hear about it, because negative reviews are just as useful as positive ones, probably more so. Oh, Joe said, I've got the UT61e DC clamp amp meter. Yeah, I've got a few Unity meters. I've got, like right here, plugged into my bench, I've got the USB power meter. So when I'm running stuff on the bench here, I plug it in through the power meter and I can see how much power it's drawing. I've got a couple of the UT61Es, and I've got another one, I can't remember which model it is, what part number, but I think it's the one that is specifically for capacitance testing. and it's got a much better range. Like it measures down to much smaller capacitance than the UT61e. Yeah, so UT139C. One thing I'm interested in with the 139C is what chip is in it, because when I started digging into this, so after I saw this on Twitter last night, I did a quick search on the UT139C and teardowns and things. The one teardown that I looked at was very short. It was just opening the cover and saying, you know, this is the circuit board inside it. It really didn't tell us very much about what's going on. UT61e, UT139C schematic. Let's see what we can find. Anyway, from what little I came across, it looked like maybe it's got an STM32 in there instead of a specialized. Ooh, what is? Let's see if we can find out a bit from here. Yes. All right, what I'm interested in is what chip is actually driving this. Is it I assume that because the specs are different, it won't be the same chip as the UT61e interfaces. It doesn't have any interfaces. Oh, that's disappointing. If it doesn't have any exposed, that probably means that whatever chip is in it doesn't have support for it. So let's see if we can find where it is. I think this is the photo we want. Oh, here we go. Here's DMM chip. DTM0. This could be interesting. Let's see if we can find the datasheet for this. Datasheet translated. Nice. So if this doesn't have a data interface on the chip itself, then basically there's nothing you can do. Not without crazy amounts of work that are way above my pay grade. So, I mean, this is squirrel chasing when we're meant to be hacking on the UT61e, but I'm curious about this because the 139C seems to be a really good viable replacement for the 61e. It's kind of equivalent specs and it's low priced, and I think it's a newer design, so it's more likely to be around for a while. Oh, it does have auto power off, and remember last time we discovered that the UT61e does actually have auto power off, but it's disabled because they just assert that pin continuously to make it think that there's a PC attached even when there isn't. Do we have... oh, there's a pin out. We could look around all the pins, but that's probably going to take a while. Let's just look through the descriptions. What have we got? Data, what? Oh no, RC clock, LVD, PWM output, frequency output, data input out. Oh no, it's just a description. Okay, it's going to say that about all of them. SPI communications. Ooh, EUART port, RC mode test, EUART port TX. Whether it actually outputs any data is another thing. So it does have a TX pin and that. So, I don't have a 139C. Otherwise, I would be pulling it apart and probing that pin. Maybe it's worth ordering a 139C just to see what it can do. Alright, let's find... no, oh, data. Okay. Data? Data. Maybe I should be searching for TX. There won't be so many. EEPROM data. Reserve power on, okay. Min-max data recording. Oh, that's looped back to the start. Alright, let's look for TX. Oh, come on. Is that the only place in the datasheet that it mentions TX? It's just right there, pin 20. All right, what about PT 1.4? Is there any other reference to that in the datasheet? No. Hang on, how can that have no references? I just copied that from right here. It's there. Or maybe because I didn't have the trail. No, surely the trailing... It's saying that that text that I just copied from the datasheet does not exist in the datasheet. PT 1.4. Okay. Only one. All right, so we're really in the dark here. We could read through more of the datasheet. Oh no, that's the end of the datasheet. That's it. That's rather sad. It's only 10 pages long. And what I was really hoping to see... Oh, hang on, UART. Here we go. UART format. So bit 76543 to 0. Low voltage power off delay. And use for NEC. UART uses 14 bytes. UART uses 15 bytes. Okay. So it looks like there is some possibility to get data out of the UT139C. However, I don't have one. So, all right, we'll just sort of park that in the back of our minds for future reference. Maybe it'll be something that can be done. But all of this, so who was it earlier said, yeah, back there someone said that did I say that I was going to solve the problem by just buying something? That would actually be the sensible thing to do. You know, if you do the calculation, okay, let's just use round numbers. If you're billing, say you're doing contract work and you're billing $100 an hour, and you could buy a $100 meter with Bluetooth in it that you'd plug in and it would just work, versus spending 2 hours or 10 hours retrofitting comms into an existing meter that you already have, you're better off just going and buying the meter. Spend the $100 and put your hours and hours of time into something that's a bit more useful. But that's not really why we're here, is it? We're here to do interesting things and learn how stuff works. So part of the reason that I'm yeah, Aaron wants to know, hey, are we technically on topic or is this a squirrel? The topic is a squirrel, and this is the squirrel's cousin, I think. So, yeah, the UT139C. It's related to the topic. It's related to the squirrel in some way. So the reason that I'm doing this is just that I like to understand how things work. And that's, I suppose, what this whole YouTube channel is about. It's about figuring things out and making them for yourself. It's not necessarily the best use of time if you just look at it from a purely economic point of view, but this is how you learn, digging things out and pulling them apart. All right, so I'll just remove my desktop for a moment because I'm going to open some things and I'll see what I had. Just looking for some, to see what I stored from last week. Projects, UT, here we go. I have a folder, oh, there's no resources. All right. Why is there an enclosure folder? There's nothing in it. I don't know. Images? Okay, so I had some stuff here. I started putting together like just a skeleton of a project. Let's make a new folder. Resources. What I really should have done last time was save the, where are we? UT61e. I can't even remember the name of the chip that's in it now. UT61e schematic. So this is a different squirrel. But something that is worth talking about sometime is how you set up your projects. UT61e. How you store all of the stuff related to it. For ES519, I think that is yeah, that's the chip that goes on it. So, datasheet. I think this is the datasheet for the multimeter chip that drives it all. Yes, it is. Okay, so what I'm going to do is save this. Come on. No, not copy. Come on. Download. Okay, so the other thing I want is the schematic for the UT61e itself. Is this it? Is this a PDF? It's just an image. Still, it's a pretty good quality image, so let's save that. Yeah, that'll do. Stick it there. So I want that. Yes, I want to move it. Don't ask me to confirm. I did it because I wanted to do it. Now, where is downloads? Come on. Datasheet. A through, where is the datasheet? Date. That one. Okay. And here is the datasheet. Alright, so starting to collect some resources for this thing. Anyway, so what I've got here is my project skeleton and notes. What did I put in notes? Is it blank? I don't remember. Let's find out. Oh no, okay, so I was taking notes. So as I was starting to dig into this, I made a notes file and stuck in just put in URLs and things. Oh look, there's the data sheet. In fact, I think this is where we just ended up. Circuit diagram, that's the one we've just got. Converting serial cable. So I stored some notes, and now we've got these things saved here. All right, so we're kind of at the starting line, almost. James offered, said, I had to run off for a second. Did you want me to drop the Unity transistor adapter around next time I'm near your place? I wonder if it would be useful. If you don't have it, if you don't have a use for it, James, I would be interested to look at it. From memory, there's not much in it. Let's open up this this schematic. And where are we? Transistor. Here it is. Yeah, what's actually inside it is just these two resistors, these two 180k resistors, and a bunch of contacts. So what this doesn't show us is the arrangement of those contacts. And as we saw when I had the picture of it up before, it's got multiple contacts in different locations with different arrangements, obviously, because pinouts are different for NPN and PNP. So what we've got here is a shared collector and a shared, no, there are two different B links here. So the base either comes off the negative or the positive, depending on whether you're checking an NPN or a PNP transistor, and the emitter always comes to the voltage input. And here we've got the common connection. So the transistor tester just arranges these 4 pins, or a subset of them, in different physical arrangements to suit the different types of transistor that you would want to plug in. But electrically, this is all that's inside it. It's not much there at all. Yeah, so ooh, looks like something odd was going on there, and Johnny has taken care of it. Thanks, Johnny. So now Okay, so James, the question was whether I wanted James to drop off the transistor tester. And thanks for the offer, but I'll say no for now. I don't have a real use for it. The only reason for grabbing it from you would be to, just to look at it and test it, see how it works. Oh, James said I'll upload a high-res image to Discord. Awesome. Cool. Well, thank you. That will hopefully show us where all the connections and things are on that adapter anyway. Now, so back to the squirrel at hand. And the squirrel that we are chasing today is data from this nice little fellow here, the ES51922, and specifically the data that appears on the base of Q4 and then modulates this infrared LED. Now, where we left it last time, I still have the stuff sitting here on my bench, getting in my way, was we pulled apart the little adapter, cut the sides off it, and now we have the infrared phototransistor that feeds into this little circuit with an RS-232 interface on it. And I bodged up this connection and we could see packets of data, but it was kind of dirty data. What I'm interested to do is, okay, there are a couple of different approaches we could take with this whole thing. The non-intrusive way of doing it is the path I was going down with this. And that is making a device that hangs on the back of the multimeter. It connects into the optical port, and we could put an ESP32 or something in it, and we just read the data off it, and then push it to MQTT or wherever we want. The other way of doing it is to put a device inside the multimeter and tap directly into the data line. So in one of these cases, in the first case, what we are doing effectively is looking at the data that comes out in this area here after we've received it, and then we can pull the data out. In the second case, if we build the device inside, we would look at what's going on the base of Q4 here. Oh, there's a 10K resistor, doesn't really matter. We could come either side of that resistor probably. So what we could do is put a digital input into a processor and find where this track is and do that. Now, there are advantages to both. Ultimately, from a usability point of view, I really like the idea of having everything integrated into the case and having it so that it is just like a UT61e multimeter, except that now it has Wi-Fi. That would be cool. But there are some issues with that. The biggest issue is power, as I've mentioned before. How are we going to power the device? And during testing, it also leads to isolation issues, because if we've got a device like a D1 Mini or a 20 Pico or whatever plugged into USB, and then that is patched into the multimeter. Now, luckily the multimeter runs off battery, so it has isolation already, but you've got to be careful with this sort of thing because you can end up with issues like ground loops or ground offsets. Ground loops aren't really the problem. It's ground offsets that are the problem, because, okay, imagine this scenario. We have a computer, which we're using for development, plugged by USB into, so we've got USB, computer, USB into the D1 Mini. D1 Mini is connected into the back of the multimeter, and they need a common ground in order to be able to do the serial comms. The multimeter is powered from a battery, and then while testing it, you use the multimeter and you plug it into some kind of a voltage source so that you can get a value off it, and then you can see what's going on. Now, I haven't actually looked at how this works, but depending on the isolation in the multimeter, you might end up with a situation where you smoke the multimeter, the D1 Mini, or your computer because of a difference in the ground reference voltage. Now, multimeters generally run off a battery in order to totally avoid that problem. It means that whatever you plug it into, it's just referenced off, you know, the load that you're measuring, and you avoid that whole problem. So the idea of hacking around on the inside of the multimeter is not that great for that reason. It would be nice to, whatever we come up with in this project, make something that you can take a regular unmodified UT61, where is it? I don't even know where I put it. The one that I was hacking around with the other day. We're gonna need it. I need to find it. What did I do? Oh, everything's a mess right now. That would be funny if I can't even find it. Oh, there it is. Okay. I was looking for it to be sitting out on a bench somewhere, but I'd actually put it back in the place where it normally goes, like its actual legitimate spot. So what would be really nice is have a totally stock UT61e, pop the little thing off the back, have another little device of some kind that we're going to come up with that hook clips into this, and that device could have its own power supply. So it might have, it could have a battery in it and power management and a USB connection so that you can plug it in for recharging, and its own separate power switch. So it would be a totally independent circuit that is not electrically coupled at all to the multimeter that we'd be hacking around on. It just reads the data coming out of the port on the back of it. So I think that is probably the direction that I would like to go with all of this. Okay. Okay, so Joe Anon said the RS232 is for the output, input is used for the display, if I recall correctly. Okay, yeah, so there was a mention of the display connection last week as well. Okay. Tyler has posted a bunch of questions, and this is not necessarily the time or place to start addressing all of these questions, but I just noticed that there are a lot that have come up in the chat, and it could be that Tyler has a serious problem with someone messing around with them. So this is not really the time for me. I don't know if I can help you, Tyler. Maybe if someone in the chat wants to talk to Tyler and find out what's going on, go for it. But I'm not really in a position to do it right now. Yeah, and as Aaron said, this is not the audience here to assist. Yeah. Oh, Peter made it. Cool. So yeah, sorry, Tyler. I don't know what's going on with you, but I can't help right now, unfortunately. I'm going to try to stick with this project. All right, so yeah. So where I'm going with this, it's kind of looping around to my original concept, which is a box that goes onto the back. So what we could do is we could use something like an ESP32 baseboard, which has its own power management built in, and there are some good candidates for that, of course, and then just have it in there with a little LiPo so that it can be recharged, and maybe a power switch on top, so you could leave it hanging on the back of the multimeter, and then when you want Wi-Fi you flick the switch and it powers up, and then it starts broadcasting the data that comes out of the port. But in the meantime, what I'm interested to do is just probe around in the data. So back to this thing here, what I'm curious to know is what is happening on this data line. So maybe that's the logical next place to take all of this. Okay, step 1, remove battery. And, oh, got an assembly overlay there from yesterday. I was assembling a batch of IO Relay 8 modules because I've had a few people say they want them and they're out of stock at the moment. They're, you know, the real thing about assembling those particular modules, like, where are they? I'll show you one. I've got this little tray of them. So this is a tray of the IO Relay 8 modules that I was just assembling yesterday. And I'll keep my fingers off them because these have already been through the ultrasonic bath and they should be absolutely perfectly pristine, clean, spick and span, I hope. And anyway, I ran these through the pick and place machine yesterday, assembled a little batch of them. And the funny thing was I just set the machine up and I was right about to hit go on the pick and place job when Alberto turned up. So Alberto is a mechanical engineer at the water cannon company for that thing. And he turned up to drop off some stuff for me. So I ran the pick and place job while he was here and he got to see the machine running, which was cool. Anyway, so I used the machine to do all of the part placement and then, so that's fine, I can run the machine all day. What really sucks about this, it's these screw terminals. I hate putting these things in. Like, I've made up assembly jigs and things so that things like, you know, all of this can be held in place, the little IDC connectors. Soldering those on isn't too bad. I can just sit there and listen to a podcast and solder those on. But what annoys me about these is assembling them. Because they come in short bits. And yes, this is a squirrel, I know. You came here for squirrels, didn't you? If there weren't squirrels, then this just wouldn't be Superhouse. So anyway, they come like this and they have to be jammed together. So you've got to align the little Duvalaki slots on the side and sort of wriggle it to get it straight and push it down, and then you grab the next one and you push it down, and then you grab the next one and you push it down, and after a while you end up with blisters on your fingers. So all right, so I've done 4 there, which is half the size of one of these, and then they end up slightly stepped. Like you can see there's a little bit of a step between them, and getting them to really push down is actually surprisingly hard. You've really got to get the angle right and push hard to make that align so that it is all straight, and it's very frustrating. So I sat here for ages last night with these just going and then soldering them on. I hate doing that. It's the worst part of the assembly. I think the worst parts of assembly are things like little screw terminals, and the other bad thing is wiring harnesses. And connectors. Like, just connectors in general suck. They're always really awkward to do. Things like crimp connectors, I hate them. So anything that involves wiring, I just dislike it. I'd rather design a circuit board than to hand wire something. So, oh, that's right. Now this is kind of a squirrel. That thing over there, the light switch controller. I was going to talk about that maybe later. All right, let's defer that squirrel. I do want to talk about that because that has taken up a lot of time this week. There have been some major changes to that. But for now, let's have a look at this. There. that one should get in there. This screw is in a very awkward position. It's right next to the 10 amp fuse, so it's a little bit hard to get to. And oh, maybe I can do it from this side. Oh no, where's the transistor? I think the transistor might be on the back. I can't remember. Let's get this PCB out and then we will find out. And then maybe we can see data coming off the chip. So even though ultimately I'm kind of leaning towards doing this as an external device rather than, you know, there is actually room in here. There is space in around this area, for example. There's a bit of volume inside the enclosure. We could stick a tiny pico in there. It would fit easily. You could put half a dozen tiny picos in there. But I'm still leaning towards making an external device. Every time I do this, I worry that I'm going to screw up and not be able to get the LCD aligned again properly, because it's got these little you know, Z-axis conductive things that it connects to the contacts. Oh, you can't see it. There it is. So there's a row of contacts across the top of the PCB, and that connects to that little rubber strip that goes along there, which is actually a whole lot of parallel conductors running through, so it passes through to the LCD. Every time I take this off, I am afraid that I'm not going to be able to get it back together again. Okay, so there is the multimeter chip, and I suspect that this up here in the corner is the transistor that is driving the data. Oh, there's an SDO. Is SDO the one we need? If there is a test point on there that does it, that would be fantastic. Or is SDO something else? No, SDO is what we want. Oh, that is so nice. Look at this. Coming down here, data pin, SDO is serial data out. And let's chuck it under the microscope, because what there is, hang on, brightness down, cut the glare. Look at that, SDO, that little test pad right there, and Q4, so this transistor up in the corner here is the one that drives the data output. So that test pad, SDO, is exactly where we want to be picking up data. Nice. Now I've just got to find a 0 volt reference somewhere, which should be handy. There should be, let's see what's going on with the circuit. There's one on the other side of the, sorry, I'm just looking at the schematic. There's one on the other side of the infrared diode. So let's find a ground point. It is positive goes to there, freaking, what's that? COM1? COM, oh, I think COM might be common, which might be, if we're lucky, COM is common, which is ground. Kind of, well, terminology, I know people will be saying, but ground, it's not actually ground. Yes, I know it's not actually ground, but I'm lazy and I use that terminology. All right, I can find out. Sorry, you can't really see what's going on right now, but I'm just going to try to buzz this out and see if that is. Oh, maybe it's not. That's interesting. COM. I would have thought that COM, oh, it says COM1. All right. So the point of all of this, hang on, I'm looking at the track. Oh, it's over, that's over there. Sorry, I know this is not very riveting viewing. No, that COM1 is not common as in 0 volts. That is something different. Now we've got, so D2 over there, and presumably those big screw terminals are ground as well. Or maybe a shield or something it could be. It may not actually be. Yeah, it looks like that might be a shield. It's not the same as negative. I'm kind of rambling here. I'm not making a whole lot of sense. Let's... Yeah, so negative is there, but not there. All right. Oh, that's interesting. Okay, so this is kind of worth mentioning. Now, what you can see here, and I haven't looked at the chat for a while, so I apologize if people are telling me things. All right, so what you can see here, this big hole is where one of the screws goes through to secure the PCB inside the enclosure. And you can see that it is specifically connected to these other things here. And if we come across here to the other side, you can see that that is the other screw connection, and it's connected to this big track. So what I think is going on is that these are connected to something like a shield connection. It's not 0 volts or ground. So if we see this track that comes across here, the one that I'm pointing at, it goes under the COM1 label, loops around it, comes down, and it comes to this via just there. That is actually 0 volts, that track right there. And it is not connected to this. So I think this is like a shield. It's probably connected to 0 volts through a ferrite or something, is my guess, but it's not just hard connected. So whatever the shield is not the 0 volts of the logic of the meter. So there's isolation there. And it's probably connected through, like on the front end of the multimeter chip, there is probably some isolation that allows it to not pass noise through. So this would, where are we? Inputs. So the inputs are connected through here. I'm not going to trace this through now. It's not directly related, but anyway, I just thought it was kind of interesting that what looks there at first glance to be like a 0 volt connection is not actually connected to logic 0 volts in the meter. So just something to be careful of. Anyway, the cathode side of the LED, now this is the infrared LED right here. The cathode side on this side, you can see the track comes down around here. There's a little bare, I'll try to be a bit more clear with my pointer. There's a little bare piece there, exposed copper. The track comes up across here, comes along the top of the board. This is the one I was just talking about before. So this is the negative side of the LED, and it comes down through to here, and it comes to that via. Now, if I connect, so I've got my other UT61e in continuity mode, and I stick one probe on the negative battery terminal, and I come down to the cathode side there of the LED, you can hear that that is 0 volts. And tracing it along here to where that little via is, that is also 0 volts. So what we can do is, anyway, this has been a very long-winded thing about just finding a ground connection. So what I'm thinking about here is how to measure this. Okay, we can put this back in the enclosure. Sorry, that beeping you're hearing is my Rigol starting up. So what I'm going to do is put all this back in the enclosure. now that we've found that we can get all of the signals that we need on, or have we? What did I find? Where was SDO? Yes, that's right. So we've now found that we can get all the signals we need on the back of the PCB. We don't actually need this out of the enclosure. I can put this back in the enclosure, and then I can stop stressing about the connections to the LCD, and they can all be kept in place and do what they need to do. So I'll try to get this back in here. One thing that they slightly skimped on with the 61E are these connections. So these banana jacks that the test leads plug into, as you can see, they are just a flat piece of steel that has been folded to like the tab coming off it and rolled. So it's got a rolled section there with a split in it, and it's just a bit dinky. It's a bit on the cheap side. It's not like a top quality banana jack. So then when you're putting the meter back together, you've got to get all these aligned with the plastic enclosure to get it back in. So I'm actually going to be quite happy to not have to take the back off this meter again. I'll not have to take the PCB out of the meter. And now you can see that because they haven't aligned properly, it's holding this up. And I don't want to damage these slightly flimsy banana jacks. Oh, come on. Okay, I think we've got it all aligned. Is it going to clip in? Oh! It really felt and sounded like it was breaking then, but I don't think it did. Alright, so let's test this. Which way? Negative, that way. Alright, so I'm just going to hold the battery on there, turn it back on and see if we have a meter that still works. It beeps. Ooh, we've got no display. You can see the backlight comes on, but we've got no display. This is exactly what I was worrying about. Well, if I've broken the display on this, this meter may now need a data connection just to become usable. All right, I'm going to take this back out and see what is going on with this LCD. So there's that rubber Z-strip stuff there. Maybe it just wasn't quite aligned properly. It's got these little alignment pins just here that go through the PCB. So I'll pop those into place. Push down on it, clip the bottom in place. Oh, this would really suck if I've just killed my multimeter. And you can see there the gap between the LCD and that little Z-strip rubber thing and the PCB. So when that is clamped together, that is supposed to make electrical contact. Or maybe I just wasn't pushing down on it. Could be as simple as that. Maybe it'll work once I screw it back together. Okay, might have been a false alarm. Put that back in place. Are the little legs coming through? I can't see. Oh yes, they are. Okay, so the little pins from the back of the LCD are coming through now. Alright, so I'll clip this back. And that tells me that it is aligned. Snap that back into place. And we probably still have, let's see if we get an LCD coming up now. We don't even get a beep. Oh, come on. Was I connecting the battery backwards? Yeah, so we've got no functioning LCD, but I'm going to screw this in and hopefully the LCD is going to work again. Otherwise, I am going to be a very sad squirrel chaser. Although, for these purposes, for our purposes of making an internet connected multimeter, it's probably not a huge deal. Although, doing things like making sure that the data we are seeing is what we expect would be rather difficult. Negative, that way. All right, come on. You better work. Yes. I saw it for a brief moment. Yes, the LCD is working. Whew, that's a relief. All right, so I needed those screws in there to push down onto that little Z contact strip. And then it worked again. I'm glad I didn't just kill a multimeter. Those little rubber strips always strike me as being a potential damage point. You see them in LCD, like also LCD wristwatches and calculators and things as well. And I've never liked them. They always seem like black magic to me. All right, so now we're back to having a working multimeter. Probably, yes. And we now know that we can take ground from either the negative side of the LED or from the battery terminal. And we've got SDO, so serial data out, right there. And that is the data pin coming out of the chip. So, let's take the soldering iron to my multimeter. This doesn't make me nervous at all. Not in the slightest. Because what I want to do is just connect on a little patch lead. Sorry, what else? I've really lost the plot. What am I doing? All right, I just want to have somewhere that I can connect a probe onto this. So, just going to turn on my little extraction fan while I solder this, which is going to make a bit of noise. But that's what you have to put up with in order to not be breathing the nasty fumes. All right, so let's just get some, how can I get the easiest angle on this? And where is it that you can see it? Okay, right about there. Which way to focus? About there, okay. Just going to solder a little wire onto that test point on the PCB. So I'll just tin the wire first. I tin the test point first. Now what I'd like to be able to do is bring this wire out. In fact, bring both the wires out. I'd like to bring out a ground wire and a data line and put the back cover back on. I wonder if I can bring it out through there. What can I use? Oh, I know what I can do. I can pass it through. Oh. I can pass it through the hole. In the back here, we've got the two data ports, the optical ports. What I was just thinking of doing was popping the cover out, but no, it's been heat welded in place, and I don't want to. I'm trying to avoid breaking stuff, basically. There's a spot in the case. I'm just looking for holes in the case that I can pass some wires out through and still be able to have the case closed, because that way I can have the battery in it and it's just much more robust. Now, I think I am going to take the back cover out of this. So this is what I'm talking about. There is this little clear cover here, and this goes through and covers the two optical ports. One's the transmit port, one's the receive port. And the receive port is not actually, it's not used for anything. There's nothing inside the multimeter. You can see the transmit port here with the infrared LED. This is where the receive port would be, and there's nothing there. So if I take this out, can I get this little heat weld thing off? It's kind of, it's very flush. Can't even get the cutters onto it properly. Just trying to remove that so that I can pop this cover out. Can I cut it a bit? Try to do it in the least invasive way possible. Doesn't want to come out. Come on. Ooh, maybe that was it. There we go. Yes, I think that might have done it. Yep. Alright, so we got that out. And that means that if I connect a couple of wires to the inside of the multimeter, we'll be able to pass them out through that port and put the cover back on. So I'm going to use, unfortunately I don't have any black wire wrap wire here, so I'm going to use blue for the 0 volt connection and yellow for the data connection. What do we have? I'm just going to connect onto the LED and solder this in here. Alright, and then the data connection, I'm just going to solder onto the test point on the PCB, which is right there. Sorry if I'm sticking my head in the way. No, not too bad. And then we can feed those through the case. Like that. Through you go. And close the case up. So now we have connections to the 0 volt reference inside the multimeter and the data pin. So this is now directly connected to the serial data output of the multimeter chip. And let's try, which way does this go? Plus, minus, that way. So I'll put the battery back in the meter. Come on. Oh, turn it off. Screw it closed. I'm not going to bother with the other 2 screws just yet. And let's see if we can see any useful stuff coming out of this port. Now, this is going to take a little bit of jiggery-pokery to set up, and initially you're not going to be able to see anything from your vantage point stuck in the camera in there. Now, what do we have here? I will just get myself all arranged here, and then hopefully I will be able to give you a view of what's going on. And there we go. Just going to change the vertical scale a bit, and then I will show you what we're looking at. And it does indeed seem that we have a packet of data coming out there. Now, run. All right. What do I need? Okay, I need a tripod. I need my phone. I need video going into OBS so that you can see the oscilloscope. All right. I am not very organized. Not very organized at all. Okay. So, where are we? Where are we? Okay. Sorry, I am temporarily discombobulated. All right, we're heading towards the end of our time together today, but we are going to see some data coming out of this. Firefight said there are quite a few references online to adding low power and cost Bluetooth modules to the UT61e. One in particular, Jake's blog, covers installation and there's also a software toolkit. Yes, there's there are many, yeah, there are many UT61e hacks. I don't know if I've seen that one that you referenced, Jake's blog in particular. That is worth checking out. In fact, before I go any further with this, while I'm still thinking about that, that's let's switch back to desktop and close this. So notes, stock markdown. This is where I've been sticking some of the things that I found. So let's have a look. Jake UT61e Bluetooth. Let's see if this finds, looks like it might do. Bluetooth mod with an HM11. Coolio. Now, over Bluetooth, HM11, HM10, which I don't think I have an HM11, but I've got a few other BLE modules here. So I'm going to make a note of that one and stick this in here. All right. Thanks Firefight for that tip. I haven't actually seen that one before. So yeah, I've been looking around and I've seen a bunch of different hacks for the UT61e, but that specific one, oh look at this, cool. So they've taken it off that same point, SDO. So power connection, yeah, I kind of like this. Oh, and he's added a switch. Okay. There is a convenient pad labeled SDO, which is a TX line. Yep. And what is the switch for? To disable Bluetooth transmission to increase battery life. Yep. So multimeter draws 2 milliamps when not in use. Okay, so what Jake did was use the make up a little thing here which clips into this back cover. In fact, I think that is the back cover. That's the little bit of plastic that comes. It's just a thing that fills the hole, and then put a switch inside it so that you can pop it open and turn the switch on or off in order to enable or disable the Bluetooth. So that's kind of cool. All right, that is definitely worth looking at. So it says the HM11 draws about 9 milliamps from the 3.3 volt rail. Yeah, okay, cool. Thanks, Firefight. Now, what was I doing? That's right, I was getting things set up so that you could see this data packet. And just to make it easy, I'm going to grab this tripod and stick my phone on it. Now, I have no idea if this is going to work because I was using Droid Cam on this, and I haven't actually done this since switching to this computer. So let's see if we can get Wi-Fi IP 252 Droid Cam. Okay, hopefully this will work, because I think what happened, the way this works is that OBS connects to the phone, not the other way around. So if I go, where are we? Portable. Is it going to work? Yes, it works. Awesome. Okay. Now I've just got to get a little bit of zoomage. Can I zoom from here? I can. Ooh. Okay. So what we can see here is the scope, which is currently looking, and I ran a capture on it, so I'm just going to put it back into run mode again. So it's now just running, and you can see flickering across the screen occasionally. It's getting these bursts of activity, which are the data packets coming through. So there should be 2 per second. So if I stick this into single shot mode and let it capture, you can see that it has just captured a chunk of data. In fact, I'll just run it again. So it makes it a bit easier to see when the time base is set like that. So I'll just put it into single mode, zoom in, and here we have the data coming out of the port. So as you can see, we are getting data, and that will be the 7-bit serial data that we were talking about last time. So in the data sheet, it had the specs for what that should look like. But that is the data packet of a reading, effectively reading 0 volts because there's nothing connected to it. But that is the data packet that just came out of the meter a moment ago, captured on the scope. So we do have some data, which is nice. Okay. Now in that view, you can see, you can see the meter just sitting there on the bench, and very thin. In fact, I don't think you can even see them. On that camera, there are the very thin wires coming. It looks magic. It's like there's nothing connected to it, but there are very thin wires coming out of it, going to the oscilloscope probes. All right. Okay. If this was a drinking game, if we had a drinking game on this, what would the drink thing be? If it was squirrels, we would end up, I was going to say very drunk, but I'm only drinking Pepsi. I'm never going to get drunk on that. Hang on, who said Coolio? Did I say Coolio? I didn't even realize that I said it. Kraken. Release the Kraken. So what's the spring? Oh, Aaron said, hang on. Okay, there are some interesting little questions here in the chat. So Aaron said, is it safety to stop you using it whilst open, as in disable screen? No. So yeah, so what Aaron is talking about there is that spring that is on the inside of the multimeter sticking up. And no, that spring is to make contact with the shield that is in the back part of the case, and to provide more shielding around the internals of the multimeter. Now, we are at 11:50 AM, nearly at the end of 2 hours, and once again we've made effectively 0 progress. Pancake! Thank you for the 5 Kanga bucks. Pancake said, I left something for you in Slack chat. I am so slack at keeping track of Slack. Hang on, I'm gonna jump across. Now may not be the time to be looking at this, but Pancake says that he has left me something, and so Andrew, who is Pancake Legend, a low profile hardware design for the Zero Stick. Ooh, okay. That is something that that is a squirrel that I am very, very tempted to chase. Oh, is that a render? That's beautiful. Okay, I'm gonna drag this across. This is a squirrel. This is not what not the subject that we're on today. But Andrew has done some amazing work here. ZeroPad. So it is a low-profile hardware design for the Zero Stick. Light controller update. That is what I'm wanting to get to before, the day is over. I will get to that. This is a brief intermission on the way to the light switch controller before I wrap it up. So this is a design to measure X and Y axis force in a very low profile design. Now, for context, last week I showed this, and a number of times I have shown this. So this is the Zero Stick. There are two load cells mounted at 90 degrees to each other. So it's a joystick that doesn't move. And basically, just by applying force to it and changing how hard you push, it's like moving a joystick a different amount. And this is for use by people who have reduced range of motion. For example, someone who has Duchenne muscular dystrophy can use this, and they don't need to move their fingers in order to move the joystick. All they do is apply more force. So it's a zero deflection joystick. And this one is currently set up to emulate a mouse, so I can plug this into my computer and drive the computer, and it works really nicely. Oh, and this thing, which I went over to Chris's place yesterday and did a brief test, this is a thing to give an I2C interface to a wheelchair controller, and it didn't work. But we'll be debugging that this week. Anyway, the point of all of that is that Zero Stick project relates to this. So Andrew has been experimenting with different designs, and look at this. This is beautiful. Now that looks like it's actually printed. This looks real. I think this top one, that's a render. This is real. Very, very cool. So those parts on here, these are 3D printed. They're not really load cells. But what it looks like is Andrew has gone ahead and made an alternate arrangement for an input device, like so an assistive technology input device. And instead of having the two load cells mounted vertically, they are mounted horizontally, and then there is a mechanism that translates the force applied to the center point to the load cells in the X and Y axes. So, and the load cells can read positive and negative pressure, so they can read deflections in both directions. This is really nice. Andrew, I'm impressed. Very, very nice work. So we've got to catch up sometime, meet up in person, because I haven't seen you for ages. And I've got some of these load cells. So what we can do is combine the load cells that I have with the 3D printed structure that you've got. And yeah, Aaron said, nice engineering solution, Pancake Legend. Yeah. So Pancake does amazing design work. Really, really pretty and functional and nice. So let's zoom in on this render and admire it. Okay. Now, thanks Andrew. I really appreciate seeing that design. That's really cool. Now, yes, so Pancake, you were meant to be coming over here for a barbecue, and I never got around to arranging the barbecue. I'm sorry about that. So, what am I looking at? Eagle. And I'm getting into Eagle because I'm going to show you some updates to the light switch project. Now, before I get into this, because this is going to be the last thing I talk about today, okay, quick wrap up time on this UT61e. Where are we at with this? What is going on? I really hate it when people say, "What is up, YouTube?" But I just had the urge to say it right then. So, okay, we can see there is data coming off this. We can see the packets on the scope. And I think maybe the next thing to do is to connect this data pin. So this one is SDO to an ESP32, and I'm just going to turn off my scope because the fan is annoyingly loud. And turn off the fume thing and turn off, oh, the soldering iron is off. Good. And basically just connect this to the serial input on an ESP32 and set it up so that it has got the correct thing. In fact, I did a little bit of messing around with this. I shouldn't have closed that window. Now I've got to get back into it. Superhouse projects. I'm going to pull this up and show you what I did that we can continue with. Same bat time, same bat place next week. And where are we? Firmware. Okay. I'm just going to open this off screen, as in off stream, before I show it to you, because when you open Arduino IDE, it opens all the previously opened, well, whatever sketches you had open previously, it opens. And it's quite likely that I have client project stuff on there, which I shouldn't be disclosing on a live stream. So I'm opening. Aaron said we soldered 2 wires in 2 hours, so ETA is next year sometime. No, I think next year sometime is being optimistic, Aaron. At this rate. Yeah, we're going to be running into the Y2036 bug before we get this project done. Zero stick firmware. Okay, yes, I did have some customer stuff open, which light switch control, MQTT, yeah. Zero stick firmware, that's all right. Okay, so back to my desktop. Here we go. What I've done in preparation, I haven't actually run either of those things. I've just created them. What I've got are 2 projects. One is UT61e serial reflector. Let's have a look at that to start with. And what this does, it's just a slightly modified version of the example serial reflector that, you know, the demo that's in the Arduino IDE. And what it does is open a regular serial port, which is the hardware serial port, and then it opens serial 1, which is the second hardware UART on the ESP32, and it opens it at 19,200, and the baud rate, oh, not the baud rate, the encoding is a little bit unusual. Instead of just being, so typically when you open a serial port, it will be what's known as 8N1. So that's 8 bits, so 8 data bits, no parity, which is the N, and 1 stop bit. So this one is a little bit strange. Instead of being 8N1, it is 701. So it's 7 data bits, and then it's odd parity, not even parity, and 1 stop bit. So anyway, this will open a serial connection at 19,200 bits a second, 7 data bits, odd parity, 1 stop, which according to the specifications, like the data sheet for that multimeter chip, that is what we need. And then all it does is, if data is available on serial 1, it just writes that value, whatever it reads on port 1, it just writes out to the other serial port. Anyway, what this will do is turn an ESP32 into a bridge. Takes data in 1 serial port at 1 baud rate and with one type of encoding, and it pumps it out the other serial port so that we can see it. So with this sketch loaded onto an ESP32 and then the connection to the multimeter, we should be able to connect USB and just see the data coming out. That's the idea. Totally untested. What have I got this set up for at the moment? Arduino Xiao, because I was working on the 0 stick. But if I go to ESP32 dev module, I think I got as far basically as making sure these things compile, the things I'm about to show you. So come on, you can do it. It takes a while to change modes from one processor to another. Okay, here we go. So now, yeah, anyway, none of that matters. So this will, it should compile. It's not a whole lot there to not compile. And the other one, so that is a serial reflector. So that's the very first thing I want to do. Next thing I want to do, and this is what I was expecting to be doing today, is just taking that data that comes out of the multimeter, sticking it into an ESP32, running this program, and watching the data coming out of it. And then we can do decoding or whatever we want to do. So then, assuming that works, this is like the minimum. Oh, come on, are you still compiling? Yeah, it takes a while. So this is like the minimum thing. It's just taking the data out of that SDO. Hurry up. I'm waiting for you to finish. Anyway, okay. And the other one is this one. So UT61e Wi-Fi. This sketch, this is actually a copy of the air quality sensor firmware. And I spent a while just, oh, in fact it even says particulate matter sensor firmware. It still says it. So what I did was I just duplicated that project and then ripped the guts out of it. So I need to, because I just wanted the basics. Like I wanted something that will connect to Wi-Fi and connect to an MQTT broker and publish some stuff. So my plan is to mash it together. So whatever is going on here, and it's very short now because I've ripped out all of the stuff related to the air quality sensor. I'm not even sure if this compiles right now. But this is basically going to be a starting point. So what we want it to be able to do, where are we? In the loop. All right. So right now, what this is doing is every time around the loop, it just generates a random number, prints it to the serial port, and publishes it to MQTT. Waits 3 seconds, and then does it again. In fact, I need to get rid of that delay. That's bad. That'll stop it from, that'll stop MQTT from working properly. So what the plan is to do is in here, just take the USB serial reflector thing. So open the serial port from the multimeter, read it, maybe do some decoding on it so we can figure out what mode the multimeter is in and all that sort of stuff, and then publish the data to MQTT. So anyway, I got as far as, you know, mocking up or skeletoning up these projects so that we can get on to playing with those in the future. No. Now, Eagle projects, I2C RJ45. Okay, now, I'm going to start with, all right, I'm going to go back to the previous one so you got context. This is the one, this is the, where is it, version 2.1. This is the version 2.1 board that, that you would have seen in the past. And this one is, I thought there was one right here, somewhere. I had it all out yesterday. Oh, it's back in the box. It's too obvious. That's what's going on. All right, I have 2 incomplete ones here, and I'll bring some other stuff over to show you as well. So, So this, which one is this? This is version 1.0. So this is the first one I did. So it's the RJ40, 24 port RJ45 breakout with I2C, and you can see it doesn't have any of the MCP2307s on here because I ran out of them and I pulled them off here to put them onto another board. And then you can see this one is the version 2.0 board, and it's got the MCP2307Es on it, but it doesn't have the RJ45 sockets or the pass-through or anything, well, pass-through down here or anything else. So, and then there was another one that I did. So this, the version 2.0, I actually just posted one to Sumner Boy a couple of days ago. So there is a complete one of these going to Sumner Boy. And the difference between these, let's stick it over here, then you'll be able to see it a bit better. Go gadget overhead camera. All right. And I'll bring up my own preview so I can see. All right, so this is the version 1.0 board. So this was the first one I did. And you can see that on the end here, it's got a 6-way connector, which has got I2C and power and int. So that's the interrupt output coming from the MCPs, and VN. There's no reset connection on there, and that's the only connection to it. And this was before I really thought about standardizing on I2C connection. So what you can see on this is there, instead of the 1x6 header, it's got a little IDC header, unpopulated, and that is the I2C breakout header that I've been using on lots of projects now since then, because it means I can use IDC cables. So that's really the major difference between the version 1.0 and the version 2.0. And, oh, in fact, that printout, it looks huge. It's just printed on an A4 sheet. That is the pinout that I use for I2C. I don't even remember why I've got that there. So that was the major thing. Okay, so this brings us kind of up to date. This is the version that I've been testing and it's been working. I don't have a fully populated version of this right now because the only one that I had that was fully populated, I posted to Sumner Boy. So I don't have that here right now. Other things of interest. So this is the front panel controller thing. So this mounts through the front panel and it's got menu buttons and the LCD on it. And you can see on this one, it's got the IDC connection. So this is 2 of the I2C breakouts, and they're just connected directly to each other. It's a pass-through. And the reason for that is that you can daisy chain them together. So what you do is have, you have, for example, in fact, I took a photo of this. There, I have a better way of showing this to you. Let's see if I can find it. And let's see if I can find it. Pancake said, "Lol, it's not SAO compatible." No, it's not. I did this before I knew of SAOs. In fact, I think I did this before the 6-pin version of the SAO was developed. I don't know what the date of this is. It's a couple of years I've had this design and then just not followed through on it. Are those display boards available, Dodgy asked. Not yet, but they will be. So anyway, wow. Well, what am I doing? Okay, what I'm looking for is, I took a couple of photos just before I sent off the boards to Sumner Boy, who's going to do some software development on this and do some testing. So, and the photos are the best representation of how all of this hooks together. Here we go. All right, now, desktop. Come on, desktop. There we go. All right, now I'll shrink this down a little bit so that you can see all of it. Now, this is not in an enclosure, but this is approximately how it would be wired up in an enclosure. So we've got the RJ45 breakout at the front here, and this would be mounted through the front panel. Down on the bottom right, we've got the control panel. So it's got the LCD and the buttons. And you can see the I2C connector here. There is a cable that goes through and it goes onto this board. And then there's another I2C cable that comes out here and it goes onto this shield. Now you can see the Freetronics box in there. There's actually an Ether 10 inside the box. I didn't bother taking it out of the box. But that represents where the Arduino or the Pi or whatever little computer you want to use to run this, this is where it would go. And then there is a shield or a Pi hat or whatever that plugs into it, and that gives it the I2C connection. And then this pass-through Ethernet comes from the front panel, then you use a patch cable and you plug it into your board down the back there. And this gives you a self-contained little thing. So this shield here that you can see, this is a hand-assembled proto shield. It's got a watchdog timer on it, it's got the I2C breakout. I haven't actually produced the real thing yet, but I'm going to have boards designed. I've already laid it out in Eagle to do that properly. And I don't know, what I'm talking about doesn't even make a whole lot of sense. I'm kind of rambling. And anyway, okay, so to get back to this. This is what I've had for a couple of years now. In fact, I think 2017, I might have done the first version of this board, which is just ridiculous that I still haven't even released it yet. So we've got this one. So what I did during the week was I had a good long think and listened to a bunch of feedback about whether this whole end of the PCB should even be there. This is where the pass-through is. So we've got Ethernet coming through the front panel, passes through to the back, and then it goes through to whatever board you have. And there's a power connection here as well. But it seems that there are different ideas about what all of this should be connected to. So I decided that it would make sense to make a version of this board that didn't have this left end. It would only have this portion of it, and then that could be coupled with however you want to connect things through here. So what I've got is, so what I ended up doing was I took the 24 port board and I stripped it down. I'm just going to turn off a back layer here to make it a bit easier to see. So what we've got here is a version of that 24 port board, but that whole left end is missing. It is just the breakouts for the RJ45 ports, and you can see that I've also doubled up the I2C breakout here. So we've got one at this end and then we've got one at this end, and that means that you can connect from either end, and you can also daisy chain. You can't daisy chain more of these because you run out of I2C addresses on the MCP23017s, but you can put, for example, you could mount the control panel at the left end instead of the right end if you wanted to, and just have a nice short cable going to it. So I ended up doing a big revision on this, and I went through and actually made all of the tracks thicker and improved the routing. So it was, yeah, it was a really big revision. Some of you might be looking at this and thinking, why did you bring that up through a via? Take that through a via, take it to the other side of the board and then bring it back again. There is actually a reason for that. That is to prevent splitting the ground plane. It's and you can see the same thing happens down here and down here. It's that was all to optimize the pores of the polygons on the top and bottom of the PCB. So anyway, what I did was do this new 24 port board, and I previously had 8 port and 16 port versions as well. But because I had put a lot of work into optimizing all of this routing, what I ended up doing was then scrapping the existing 8 and 16 port boards. I duplicated this one, and then I just deleted a bunch of stuff and made it shorter to make the 16 port version. And then I copied it again, deleted a bunch more stuff and made it shorter. So what we end up with is we've got that as the 24 24, sorry, I'm opening some other stuff. Not that, not that. Just opening some other things here. All right, so this is the 8-port version. Once again, I'll get rid of the back layer to make it a bit easier to see what's going on. So it's an 8 RJ45 socket thing, and the I2C addresses for the two I/O chips can be totally configured using solder pads. On the previous version, I had pin headers and jumpers, and I kind of ran out of space because what I ended up doing was I changed to this I2C breakout, put one at each end, and just compressed everything, and I ran out of space, so I ended up going for solder jumpers instead of pin headers. But that's just the way it goes. So there's the 8-port version, and now the 16-port version is this one, and you've already seen the 24-port version. So what we've got now is, so if you look at this board, that part there is actually exactly the same. This is a duplicate of the PCB of the 24-port version with 8 ports on the end deleted, and then just the end of the board moved in. That's it. So it's exactly the same. I wanted it to be totally consistent. And so I now have updated versions, and this is now, as you can see, it's up to version 3.0. It'll get released eventually. So now I have updated versions of the 8, 16 and 24-port boards without the extension on the end, and with the I2C breakouts on both ends. So I think that gives a fair bit of flexibility. And then what I need to do is think about, so going back to this, this version with the breakout on the end, what I've been thinking about doing is doing a version of a board that is essentially just this portion. And I could do a couple of different versions of it. So what I've been thinking about with this is doing one with an ESP32 on it and Ethernet. And that way the light switch controller would have both Wi-Fi and Ethernet, and it could be powered using power over Ethernet because I put PoE in the same area. And all it needs basically is a board. So this corner board would be something with an ESP32 on it, and Ethernet and PoE and an I2C breakout header, and that's it. Like it'll be a really simple little board. It's almost like a WESP32 in a different form factor, and it wouldn't need the pass-through socket on the back. And that way you could make a light switch controller and do it all with just this board and this board. Anyway, different things to think about. So where that is at right now is I haven't yet sent the updated ones off for fabrication. I've been kind of sitting on it for a couple of days while I think about whether there are any more changes that I want to make or anything else that I might want to have fabricated at the same time. But I now have the designs done for version 3. And also I've, ooh, Frank, thank you. 50 Kanga bucks for the LC Fighting Fund. Yes, Pancake said the symmetry pleases me. Yes. I also am a fan of symmetry. So when I was laying out this board, in fact, okay, I'm going to show you a little bit of the level of pedantry. Let's be pedantic about how I pronounce it. The level of pedantry that I went to with this. I'll turn that off. And the easiest way to show you this is in Fusion 360, and launching this may stress this little old iMac, but we shall see. Adam P said, do you ever run into bus capacitance issues with long I2C runs? The answer is yes. And I haven't had problems with this sort of size. Okay, I'm just just thinking about how to answer this question, because this is something that you could chase for a while. There were actually capacitance issues on the I2C bus for the ArduSat payload processor module, and what ended up happening was we had to run stronger pull-ups on the I2C bus, and that's because I had 17. Yeah, I had 17 microcontrollers on a shared I2C bus with, how many sensors did we have? So the reason for I2C in that case was it was also talking to sensors. So we had 17 microcontrollers, and I think it was 5 sensors all on the same I2C bus. So you obviously couldn't have all the microcontrollers talking at the same time. It would cause some problems. So there was some contention handling around that. But while I'm waiting for Fusion 360 to load, yeah, so we had some issues with capacitance on that bus, and we fixed that by going to stronger pull-ups. Come on, Fusion. But on the light switch controller, on the prototypes that I've had running on the bench, I haven't had that problem. Is the very short version of the summary. All right. Fusion 360 is slowly opening. And, oh, we're even in the correct project, because this is what I had most recently. Adam said, I was using it for soil moisture sensors a few feet away and ended up using the LTC4311 active pull-ups. Interesting. LTC4311. I don't think I've come across that before. While Fusion 360, oh, it looks like it might have finished opening. Hooray! All right, now I'm going to open up several projects here, which it might take a while. Low voltage, so the LTC4311, low voltage I2C accelerator. Dual active pull-up designed to enhance data transmission speed and reliability. That's really cool. Adam P, thank you for that tip. I hadn't come across that chip before. Oh, I just loaded the wrong one. What I wanted to open was this one, and this one, and this one. Opening. So, so what I have now are 4 versions of this I2C RJ45 breakout. Now, if it finishes loading, all right, I'm going to go back to reading about this I2C bus accelerator. Oh, okay, it's finished. All right, so this one. This is the existing one. So this is the version 2.1 with the pass-through, which is how it was up until, last week, whenever it was, before I started my multi-day hacking session redoing this. Now, what I ended up with was this, which is the new trimmed down 24-port version. And you can see it's got the I2C breakout on each end. And then we've got the 16-port version and the 8-port version. Now, as I was doing this, I was specifically planning that I would put all of my effort into the 24-port version and get it just right, exactly how I wanted it to. And then in the schematic, I could just delete all of these parts, move the right-hand edge in, and make the 16-port version, and then repeat the process and make the 8-port version. So as I was doing that, I was planning ahead, and you can see here that the left side is the bit that's going to be common to all of them. And you can see that there isn't much in terms of silkscreen on the right-hand side, because that was going to get deleted. So what I did was I tried to squash all of the useful information onto the left side here. And if we come to this one, you'll see that it's the same, and this one, it's the same almost, except that I had to make compromises because of those addresses. But things like the logo position, all of this down here, the interrupt header, the LEDs, they're the same. They're exactly the same. And on the back of the PCB, this kind of irks me a little bit, but it makes sense. You can see that I put the silk screen on the right. So on this one, the 24-port version that I did first, I put all of the useful information jammed into this third of the board, which means that it's across to one side when it's in the 24-port version, but it means that when I deleted the parts and just moved the edge in, you can see that these are the same. Culminating in the 8-port version, which has the other 2/3 deleted, and the silkscreen on the right part of that is just the same as the silkscreen on the others. So my goal was total consistency between the 3 boards. And if you look at that part of it right there, compared to that part of it right there, it's the same. Tracks are the same, everything is the same. I don't know why I'm emphasizing that so much. I'm kind of just rambling now, and I really should be stopping. But anyway, my point is, over the last week, I have been obsessing over the light switch controller. And trying to make it as nice as I can in terms of making it flexible, like modular, like this, with the 8, 16 and 24-port versions of this breakout, and modular in terms of what it connects to in the back end. So if we go back, do I still have my... No, I closed the photo. Does preview allow you to open recent? Yes, it does. So this thing here, that can be replaced with something different to just plug in a different microcontroller. Anyway, I really need to stop. In fact, I've got to go somewhere this afternoon, and I have a commitment that I need to attend to, so I can't just keep talking forever. I need to stop eventually. Maybe, one day. Aaron said, will be an interesting test jig for this bad boy. Yeah. Oh, that is a good question from DefPom. DefPom said, does it matter that the 8-port version doesn't have a bulk storage cap where the 16 and 24 have them? That is a very good question, and I went backwards and forwards on that. So what I ended up doing, okay, you can see here on the 24-port version, there are bulk storage caps in between the ports. So there are 2 on the 24-port version, there's 1 on the 16-port version, and there are approximately 0.0 on the 8-port version. And so the number of storage caps is n-1, where n is the number of big chunks of RJ45 connectors. So what I thought about doing was maybe trying to fit one down the side here somewhere, but there just wasn't quite enough room. And so I didn't. I could possibly fit one in here, right in the middle. So one of the options is, if we go back to like the 24-port version, one option would be to put 3 caps on this version and put them in the space here between these resistors. So there would be one behind each of the ports, and then I could have 2 on this and 1 on this. And this sort of question is the reason I haven't sent these boards off to fabrication yet. I'm still kind of debating this sort of thing. Do I do this? Do I go to the trouble of putting a bulk storage cap behind each of the ports? Maybe I will. It depends on how obsessive I get. Oh yes, so Pancake said, if you don't already, follow at PCB Arts on Twitter. Gloriously obsessive PCB design. Yes. Was it PCB Arts that did the PCB just recently that's got the weird shaped cutouts and all of the parts at strange skewed angles? That is I'm gonna check that. I know I really should have stopped the live stream by now. PCB Arts. I will stop soon. Oh, Dodgy said, what does it store in terms of the capacitance? So that is basically just decoupling the, it's decoupling for power that feeds through to the light switches that are plugged into here. So one of the reasons that I'm kind of debating this is that it doesn't really matter a whole lot. Those capacitors are not on the power rail for the ICs. Now there are decoupling caps on all the ICs. See up here? These are little 10 microfarad ceramics and there is one near to each of the MCP 23017s. So they are all nicely decoupled anyway. And if you go down to the 8-port version, you can see there are decoupling caps here. So it doesn't actually make any difference in terms of noise on these ICs. They're fine. What these bulk capacitors are doing, these are connected across VIN, which is, you know, nominally 12 volts, which supplies power out to the... I'm actually talking myself out of changing this now. So what it's doing is supplying power out to the light switches. And at the light switches, at least in the passive light switches, there is only, there are just LEDs. So with the smart switches, there's a microcontroller, but with the normally that VIN power is only illuminating LEDs in the light switches. And the LEDs are constantly on. It's not as if they're chopping or anything. So they're not inducing electrical noise. And the switches are just toggling down to ground when you press them. So from a symmetry point of view, I like the idea of having a cap behind each of these connectors. Maybe what I should do is, instead of having these big expensive electrolytics, I should just stick a small decoupling cap behind each of these. Like more of these, a 10 microfarad ceramic. Okay, I'm going to think about that. I'm going to obsess over that and no, so it wasn't PCB Arts. Was it Greg DeVille who did the crazy PCB just recently? Yeah, PCB Arts on Twitter is worth following. Let's see, I'm going to check this out. I have a feeling that, yeah, I can't remember. Someone just recently was doing a ridiculous PCB. Ah, yes, here it is. It is Greg. Check this out. Hang on, I'll bring this across so you can see it. All right. Now, for those of you who are obsessive about symmetry, etc., this is going to break your brain. So this is a render of a PCB design. Now, one thing that annoys me about this PCB, and that is the USB connector is straight. It shouldn't be. It should be on a slight skew. But apart from that, Greg nailed it. So I think this started off as kind of a joke. And it was like, oh, I'm going to do a design that's going to make everybody's eye twitch. Yeah, look at these tracks and these positions. Oh, now with curvy traces. So there are curvy traces running through here. And this was penalizing it. And because the support of the edge strip of the panel along here had this big gap, what Greg ended up doing was putting an extra piece in here with a breakaway. So there are little mouse bites along here. So it can be fabricated and well supported, and then this gets broken away. And check this out. These are the actual boards. So this is the bottom of the PCBs. And this is the top. Oh, there's something blurred out there. Look at the angle on all of these parts. That is ludicrous. And this is the board partly being assembled. Parts at weird angles. And, oh, you can see the curvy traces in there. Look at this. Ooh, nice curvy traces. Yeah, it should have been an April 1st post. Yeah, except that it's real. It's not a, it's kind of a joke, but not a joke because he's actually building it. Yeah, look at the angle on these parts. So pretty. Yeah. Yes, DRC passed, clean up. Yeah. Yes, Luke. I don't know if Luke's in the chat today, but yes, Luke said should have put a little bit of wonky angle on the USB connector. I totally agree. Okay. It is, it's heading towards 2 hours and 40 minutes of this live stream. I've got to stop. I've got to stop. All right. So, close to a 3-hour live stream. And what did we achieve today? We achieved 2 wires soldered onto a PCB and a trace on the scope. And that's it. No, these are not the most productive sessions ever, but I still enjoy it. Oh, DefPom said the board edges are parallel. That needs fixing too. I think that would be the thing that would tip it over in my head and just make it too much. You know, make it just, you know, like a, not even necessarily, not a parallelogram, but, you know, just put a little bit of skew on the board. And then maybe some mounting holes that are at random locations. Yeah. Okay, so just wrapping up. With the light switch controller before I do sign off. Where was it? So Frank said just make the 8-port and sell multiples as required. Yeah, well originally that was what I was thinking of doing, but the problem is that if you want to make something really neat, firstly it forces it further apart because you end up with more mounting holes. You end up with the little things looped around. Basically to make one like that, you know, minus those, but one like that, all as an integrated board, costs less and is smaller and neater than making 3 individual 8-port boards. I've got 8-port boards here, I think. Yeah. So that's the 8-port version. This is the old one. You can see it's before the revision. It's got the different headers on it. And that's the 16-port version. So to make 3 of these and then daisy chain them is more expensive and it takes up more space than making one of those. And my feeling is that most people are just going to go straight for the 24-port version anyway. I mean, it's a reasonable number of switches to have in a house, and you can end up adding more switches just because you can. That's the really nice thing about this sort of approach, is that you're not dependent on on mains wiring for adding control surfaces. Excuse me. So if, for example, you think, I've got a light switch on that side of the room and I want to put one on that side of the room, it makes it really easy. Just run a Cat5 cable to it and plug it in at the other end, and you've got yourself an extra light switch. No mains wiring involved. So the result is that you end up putting control surfaces in more places just because it is so easy. That's what I found anyway. So I've ended up with light switches in extra places just because, you know, it's nice to have a light switch when you walk in the back of the garage and have a light switch in the front of the garage. And so, yeah, it might sound like 24 ports is overkill, but like in a normal house, you might think, I've got a kitchen, a lounge, 2 or 3 bedrooms, and a laundry, a bathroom. You know, it's I don't need that many light switches, but it's surprising. You will add more. Aaron says, "Do I have 25 light switches?" No. Yeah. Oh yeah. So Dodgy says 24 by 4 equals 96. Yes. So this is when I say light switch, I mean like switch location. And the switch location can have up to 4 buttons on it. So you can have 96 going into this, but at 24 locations. So unless you want to do hacky things with the wires. I'm going to go. I'm really, honestly, this time I'm going to go. So thank you for coming to my TED Talk. And I will see you on Discord, or Twitter, or Facebook, or whatever, or next week. And I hope you have a great weekend. And I will talk to you all soon. Now, I've got to figure out how to end the live stream. Adam P, yes, go to sleep. I'd like to. All right, bye.